Hello guys, I am here to teach you Staad Pro. Today we'll be discussing the basics parts 1 of Staad Pro tutorials. In this part we'll be learning about a beam applied under a load. So initially select Staad Pro and new project. Since we'll be dealing with beams in 2D, so do select plane, give the structure name and select the required units, meter and kilonewton. Select next, then press add beam, select finish. You will come up with a grid which is isometric in view. You can use any view here. Select front view. As you can see, these are 10 coordinates, each of 1 meter span. The spacing can be changed in snap node beam dialog box on the right side of your screen. As you can see, the spacing you can give as 2 and press OK. Similar way, you can increase the number of coordinates. So we'll be discussing in this class about a beam with fixed supports subjected to a uniformly distributed load and nodal loads, in the sense point load. So let us take a beam of 10 meter span. So select point 0 to 10 meter span. Now you need to press escape. So this is our beam. You can switch off the grid here by selecting the grid option. Now you can see our beam. So first we'll be selecting the general tab on the left side of the screen. In general tab you need to select the property tab. In property tab you need to define the property for the beam, which is rectangle, and give the possible size to it. It might be 0.45 by 0.3, and the material is concrete, steel, whatever required. Add, close. Select the property, select the beam, assign to selected beams, assign, yes. In this way the size gets assigned. In order to see the size is assigned or not, do select right click and press 3D rendering. So you can see the size is being assigned. Now you need to assign loads. Before that we would assign supports. So select the support tab and press the create icon. Let the supports be fixed, add. Select the fixed supports and select the node cursor and press Ctrl and do select the nodes. Assign to selected nodes, assign. In this way the supports get assigned to the particular beam. Now we need to assign loads to the beam. So select loads and definition tab. You need to select load case details, add. Let the title be load case 1, add, close. Under primary loads, load case 1, select load case 1, add. Now we need to give nodal load in FY direction, which is minus 50 kilonewtons, add. And uniformly distributed load, in the sense member load, select uniform force, which is 2 minus 45 kilonewtons per meter, add, close. You need to assign these loads to the beam. So select the nodal load and do select the node cursor and select the particular nodes. Assign to selected nodes, assign, yes. In this way the loads get assigned. Now select the uniformly distributed load and using beam cursor select beam, assign to selected beams, assign. Yes, in this way the loads get assigned, but this scale runs up to infinity. So in order to scale it, the loads, select this icon, loads icon on the below the menu bar. In this way the loads get scaled. Now you need to analyze this beam subjected to uniformly distributed load and nodal loads. So select analysis and print tab next to general tab, press add, close. Now you need to select analyze in the menu bar and run analysis, save. In this way the analysis keeps going on, and finally we come up with output file, or you can go to post processing mode, or you can stay in modeling mode. Now we go to post processing mode. In this you select OK, maximize the screen, so we can see the deflection by selecting the deflection icon here, right here, and pressing Ctrl and rolling the cursor frontward in the front direction. If you roll it in the backward direction, it goes upside, so the deflection can be observed. Switch off the deflection icon, do select bending moment in the direction, it can be observed like this. Also shear force also observed in this way. So in this way we can see the required deflection, bending moment and shear force for a beam subjected to different loads. This is the end of tutorial basic parts 1. Thank you.